And thank you for coming to my talk. Today, I'll be discussing our work on measuring the carbon intensity of AI systems in cloud instances. In recent years, we've seen a tremendous growth in the research community, both in terms of the computational cost of our experiments and, as we see on this slide, the number of research projects in our field. Here we see the number of submissions to 3 of the largest conferences, and you can see this has more than doubled just in the last few years. And increasing the number of these papers, of course, are supported by experiments in the cloud. And we also know the industry usage of the cloud has grown at an even faster pace than we have adopted it in academia. According to some recent estimates, data centers make up about 1% of global electricity demand. Recent paper checklists are now also calling for authors to report emissions information, but that information primarily hasn't been available to users of the cloud. In this work, we aim to provide methodology for calculating and then examples of reporting carbon intensity of AI in cloud instances. Also note, we partnered with Microsoft Azure for this work, and so the measurements you'll see on the following slides are from that particular cloud. Our approach starts by measuring electricity consumption in the GPU specifically. We found about 75% of the electricity consumption for some simple workloads just went to the GPU. Of course, importantly, electricity consumption is a time series. Here we've represented it with this plot. Emissions per kilowatt hour is also a time series. And you might find something like these 2 time series. And then in this work, what we do is combine these 2 together to create our estimate for your workload in your region. We also look at what the emissions would have been in a variety of other regions. If you had run your experiment in a different region, you might have gotten a different set of emissions. Our goal with this paper is to provide useful measurements. That's why we evaluate across different regions, which simulates the decisions that an AI practitioner might need to make. In this plot, we explore 2 different questions. How much variation is there between different regions, and how much variation is there between different times of year? We evaluated across 16 different regions, and we found that the choice of region where you run your experiments is one of the most impactful choices that you can make. Recall, this is just electricity consumption from the GPU. It doesn't account for things like PUE, and our takeaway here is that the region really matters. If you choose the most efficient region, you will have about 1/3 of the emissions as compared to if you had chosen the least efficient. Using our methodology, we provide some of the first concrete measurements of the emissions for a wide variety of models. Here, one vertical blue bar represents the same information that I presented on the previous slide. So for example, this is training a 6 billion parameter transformer model, which we only trained for about 13% of the total amount of time it would take to fully train it. And what we found was that the emissions was about the same as the average US household emissions in an entire year. So here, our takeaway is that the largest experiments emit a tremendous amount, no matter the region, and the smallest emit very little. Thank you, and please come to our paper for more information.